Okay, so for this one, we have a hyperbola that we're trying to graph, so we want to write it in standard form. One thing that will make this one a little bit easier is when you notice that all of these numbers right here, oops, pen's upside down, all of these numbers are divisible by 4. So the very first thing I'm going to do, oops, is change that over to draw. And then I'm going to divide out 4 on both sides, and that's going to give me some easier stuff to work with. So 4 into 16 would be 4y squared. 4 there would be minus x squared. 4 into 24 would be minus 6x. 4 into 96 would be minus 24y. And 4 into 92 would be plus 23 equals 0. So now I have smaller numbers, at least to deal with in the problem. So next I'm going to get these in order and get that 23 written over to the other side. And then since this is a hyperbola, we have to pay attention to which squared term the negative's on. So in this case it's on the x. So this is leading in y, which means our graph, all of our center and our vertices are going to run parallel to the y-axis, where it's going to be it's kind of the up and down one. So let's get 4y squared and then minus 24y together. And we'll get the negative x squared and the minus 6x together. And we'll scoot that 23 over and get negative 23 there. And now I can collect or complete the square over here in both y and x. So let's take a 4 out of the y squared. And I think I'll do this as its own step right there. And that's just, remember, when we complete the square, we need to get this down to a plain square term. So whatever's in front tells you that's what you're going to need to factor out. So I'm factoring out a 4 there. This really has a little invisible negative 1 right there. So I'm going to factor out that negative, and you can think of it as a negative 1. X squared, and then here's where everyone has lots of trouble, is making sure you get the sign reversed on that 6x. Because when I factor out that negative so that I can complete the square in here, it's got to multiply back to what I have there. So negative 1 times x squared, there's that one. Negative 1 times positive 6x gets me the negative 6x. So right there, that sign is very often a trouble spot. That's going to equal negative 23. And now let's go ahead and complete the square. So this is going to go 4y squared minus 6y. Half of 6 is 3, and 3 squared would be 9. So plus 9 right there. Minus 1, x squared plus 6x. And again, half of 6 is 3. 3 squared makes 9. So plus 9 right there. And that equals negative 23. Except that since I'm putting these plus 9s over here, I have to balance that out on the right-hand side. And that's the other place where the error almost always occurs, is either this first sign when you factor out the negative, or right here when you go 4 times 9, because it looks like we're adding 9, but we're really adding 36 over here. And right here it looks like we're adding 9, but we're actually, if I distributed that through, that's actually a minus 9. So now we have 4, and then that would be y minus 3 squared. And then minus, this would be x plus 3 squared. And then let's say that'd be 27, and then minus 23 would be 4. And now we just go ahead and make this our 1, so that tells me what I got to divide through by, so dividing everything by 4. And so those cancel, so that would be y minus 3 squared. I'll go ahead and put that over 1, just kind of for emphasis. And then here, this would just be what it is, x plus 3 over 4, and that's quantity squared, equals 1. So that means my center for this thing is going to be and then here's another place, this one has all kinds of spots. People will often write down the center as yx instead of xy, or xy, just because the order is reversed. So careful not to do that. So this is negative 3 and then positive 3, because those are backwards what they're showing. This means it shifted left 3, and that means it shifted up 3. And my A is always leading. So remember, for ellipses, A has to be the big number, but for hyperbola, that is not the case. So this first one's always A, the second one's always B, or A squared, B squared, actually. So A equals 1 and B equals 2. So that's the information I need for graphing this. Let me bring the graph over here. just have it graphed already. So our center is supposed to be at -3, 3. So we count over 3 and up 3, and then there's the center. And then I think to graph these, yep, you need center and one more point. Let me go ahead and just show it up here on yours. So it's this one. So we would be going over 3 and up 3. We get that. And then the way that we use our A and our B is we use that to define the asymptote, and that's going to draw the graph. So we know this one was leading in Y, so the A is going up and down. So we would go up 1 because that's where this vertex would be. And then B is to the other side of the box, so from there we can just count over 1, 2, and then that gives us the graph. So that is how you do that. Hopefully that helps. And yeah, this is totally a hard section and all kinds of spots that have little errors. And I guess the good thing I could say about it is the next and last section of these is actually easier. Hyperbola are the hardest of the 3. You get parabolas in 9-4, and those are not as bad.